Hey folks, welcome back. So in this video we're going to talk about design basics. And if you're new to my channel, I'm going to jump in here and get started. If you're new to my channel, I am obsessed with giant scale electric model radio control aircraft. And my nickname's DAG, so welcome. And basically anything over 150 inches I like to design myself, and I start in CAD and go through all this stuff to create a flying model. But one of the things that, and actually the plane I'm flying right now has a 188-inch wing and weighs about 61 pounds. But I get a lot of private messages through Facebook and a lot of emails through my Gmail, which I share a lot on my YouTube. Could I do a really kind of a design basics of how I get started? I've done how I design airframes and stuff like that, but this video is going to be talking a little bit more about just things you have to consider if you're going to try to design your own airframe or your own 3D printed engines. I mean, this airplane right here has a 2-row radial on it that I 3D printed and designed in Fusion 360. But when you think about something basic, like I'm going to talk about this Mercedes engine quite a bit in this video, just for an example. I'm not going to tell you how to design it, but I'm going to talk about some of the thought processes that go into the way I do design. So, you know, this was created in Fusion 360 as 87 parts. It has 58 bolts, and they're nylon bolts and nuts that come from a master car, and they look really scale. They're 440 and 256. So when you think about design, think about things you can buy that you don't have to create yourself. Bolts and nuts. Nobody wants to create them themselves. And the springs on it came from a master car. They're little bitty springs that make the valve springs on this. So this engine is actually, this 3D printed engine is the most popular engine when I used to sell them, that people bought for model aircraft, World War I vintage type aircraft. And the reason I quit 3D printing and selling them is because I found out that I just don't like a lot of people that buy things. They think they're getting something and then they say they're not, and they want to rip me off. Just part of the problem of trying to take care of people. But today what we're going to talk about is some basic things that I've learned to do in design, okay? And it's sketching it out manually. It's using CAD, 3D design, CAD like in 2D, 3D design like Fusion 360, and then the creativity and the imagination. I'm going to talk about some in this. But before I jump into this, I created a little video that I want to subliminally, kind of like Clockwork Orange, into your brain. So many of us see videos like this online for software. You know, we see somebody tinkering with a part and they're putting a caliper on it, which makes no sense because they've already measured the part. You got somebody rotating some kind of a EDF or a jet engine or a turbine or who knows what that is. Oh, and having their Starbucks. You see all of these subliminal messages about how fun design is, collaboration and all of that. And that's not really the reality of it. You know, we are so many times sold something that's a lot easier to do than it really is. And you need to understand what that means for you. You know, you always see like the pretty redhead, she's on Zoom talking about, oh yeah, we design everything and I was born designing. And, you know, then you see this pan of, you know, a technical drawing. This is subliminally trying to bait you in to thinking that a lot of this stuff is super easy. Like the only time I've ever used calipers to measure something like this, it's because I'm trying to replicate, or in this thing, it might be industrial espionage because they're stealing somebody else's plan. This probably could be in China. But the reality is this sketch right here is where most of my design started, is in a sketch. Okay? So what I want to do in this video is share kind of where my brain goes. As most of you know, I have no schooling in this. I taught myself AutoCAD about 25 years ago. I learned on 3ds Max how to do the 3D stuff, and then I got Fusion 360. And actually, when I learned on AutoCAD, it was called BricsCAD because I couldn't afford AutoCAD back then. And I'm going to talk about affording software too, because if you want to design, you're going to have some software. And today it's not cheap. So when I go to design an engine like this, okay, that I know is going to be 3D printed and I know it's going to go into a model aircraft, a couple of things is it's got to look somewhat scale and it's got to be light. Nobody wants to put anything heavy in a model aircraft or even a full-scale aircraft. So I always go out there and try to find what I call documentation. And the documentation starts with photos of the real subject that I'm going to design. And I'm going to explain in a minute why I use the word design, because I've had people say, well, you're not really designing, you're copying. I disagree, and I'll tell you why in a minute. So you just got to get really good documentation, folks. And I mean, it's really, really important that you find everything. And then you have to decide to yourself, how scale is scale enough? If you want it to be good from 15 feet away, that's a certain scale level. If you want to be good 5 inches away, totally different scale level. Okay? But normally on the internet and Google, and it takes time, it can take weeks, typing in different names for the Mercedes engine, typing in different aircraft it was in, typing in all kinds of crap to find the best drawings that you could find to make this work. You also have the option to go into museums and taking pictures. Now, I didn't take any of these pictures. These are pictures that were sent to me or just, I have all kinds of fans send me. When I say I'm going to design something, everybody just sends me this stuff. But I have gone to a couple of museums looking at radial engines and taking pictures of radial engines, but not the inline six, okay? Another thing that's fascinating when you're starting to think about designing something like this is how did they do it 100 years ago? I am still totally fascinated today that we had the machining and the lathes and just the craftsmanship to do this 100 years ago. I mean, that just blows my mind. But then when you start thinking about design, you got to think about the printability of it. Okay, how hard is it going to be to print? This was a prototype of one of my finished, I call this the upper half of the Mercedes engine. And this worked out great. Now, I don't have the valves on it or any of the rocker arms or anything, but this is where it kind of started. And this is what a full-blown kit looked like before I would send it to somebody. Okay, and then I messed around with what I call the top 3/4 of the engine. But what I want to do now is jump over to my Fusion 360. But I want to start here. So when you think of, you know, there was about 40 hours involved in drawing this, believe it or not. Some people thought it would be like thousands, but you know, I've gotten proficient enough with Fusion 360 that there's only about 40 hours in making this. And keep in mind, you can copy and kind of paste or duplicate parts. So you don't draw all 6 cylinders separately. However, cylinder 1 and cylinder 6 are different than 2, 3, and 4, and 5, because of the way some of it fits together, like the cooling and stuff on the real one. But the reason I talk about that I designed this is because I've got to create it so it can be 3D printed, and I got to create it to be light, and I got to create it to be structural. So I'm not just copying, I'm designing this for the application I'm going to put it into my airplane, okay? But when we talk about imagination and creativity, your imagination's got to be thick enough that you can kind of draw isometrically at first, because I start everything in a sketch, okay? When I think of the very first thought I had of doing this engine, I went out and got documentation first, and then I actually printed out on 8.5 by 11 almost all the documentation I got and laid it on my table. And I would sketch a cylinder and then the base plate, and I would create a bill of material with it. So basically I was building my initial bill of materials of what I was going to have to draw with a software. Now, if you watch my airframe videos, you know I design my airframes in 2D and then bring them into 3D so I can assemble the airplane. But landing gears, 3D motors and engines, and bomb bay door systems, I start in 3D. the reason I start the airframes in 2D is because I'm going to plot that airframe out on my 42-inch plotter, cut the parts out, and then glue it together. So I want to start in the same format that I'm going to print. And this is just for me, okay? If you've watched my YouTube, I'm only trying to share what I'm successful at. I don't try to tell you what I think is going to work. I only share you how I do it, so hopefully you can go off and replicate it, okay? But when I know I'm going to do something in 3D, I will try to do, and if you don't know what an isometric drawing is, go on YouTube and type in isometric drawing. Basically, you're drawing a 3D, you're drawing a visual of a 3D drawing. And by creating all of these pieces, not even the engine assembled, I'll draw a cylinder, I'll draw the rocker arms, I'll draw like the valves, I'll draw the base, the exhaust system, and I'll pull all these parts to it. Then the next thing I've got to do is actually go into my 3D software and decide what scale is this going to be. Now, if you've downloaded the right document, you've found drawing somewhere that shows what the dimension of the real engine is. And in 3D, I normally draw the engine full scale, and then I can scale it to quarter, third, whatever I want. So, but when you start thinking about the imagination you need to have, you need to imagine what this thing's going to look like done. And then you need to imagine what each part's going to look like and how you're going to get there. And then you need to be creative enough to know, okay, how thick should the wall of the cylinders be? How thick should the base be? Because you're trying to build light, okay? So I'm going to go back into this for a minute, but now I want to talk about the printability. If you notice right here, this cylinder is created in 2 halves, but that's not how I drew it. When I originally CAD'd this or drew it, I drew it as a single cylinder, created a plane through the middle of it, and then sliced it in half or split it or whatever you want to call it. And I did that so I could print it. Because what I want to show you now is the software that I have to use to turn this into a printable file. So as you see this sitting on my print bed, I can go into this software right here. Let me drag this over here. I'm going to turn off the support for a minute. Well, hang on, I can turn off the support right there. And hit OK. So when I create this part right now, it looks like this. And right here, this is kind of what it will look like when it prints. So it will start here, and it will print right up off my print bed. But the problem that I have is when it gets right to here, there is nothing supporting this right here. And this is usually ABS or ASA, and this will either start to curl up a little bit or it will start to sag. So when you create a 3D printed part, you need to think about, how am I going to support all these different pieces and parts? And now when I do this, you're going to see there's a support that prints up in the middle there. And that's what holds up the center of the cylinder. Now, if I were to print a radial cylinder that has all the cooling vents, and I drew it as, and I've seen people do this, and it's maddening to me. They draw the whole cylinder as one piece, and they let it grow off their table, and they're using support for every cooling fin. If you cut that cylinder in half and lay it down, all the cooling fins are arches that are supporting themselves. So you need to be able to, it doesn't matter if you're flying a full-scale airplane or a model airplane, you always want to be ahead of the airplane. You don't want the airplane flying you. You want to know where you're going to go. And with design, that is super, super important. So when we get back to thinking about the basic principles for me of what design is I start with a subject, I get the documentation, I do the sketches, and then I go into the software. But what I want to talk about now is to make this, and you can see behind this is another prototype that was a little bit more finished. When you go to do this, this is where the frustration comes from. So I showed you that video at the beginning which was all marketing. And when you watch that marketing, it looks like everybody's just having a joyous time with CAD and they're just drawing. The realities of CAD is I taught myself everything I know. Well, I need to qualify that. I taught myself AutoCAD and taught myself 3ds Max. And then I went and got Fusion 360 down the road. And there's a guy on YouTube named Lars Christensen. And if you want to learn everything Fusion 360, go watch him. That's one reason I don't do videos teaching you how to use Fusion 360 is because he is by far the professor of this stuff, okay? But when you're thinking about learning how to use it from scratch, and you see all of this marketing and advertising of all these cool things drawn, these are people that have done it for years. I mean, I started AutoCAD 25 years ago and 3D about 19 years ago. And I've gotten pretty damn good. But the reality is, I probably only know 30% of the software. There's so much more it can do that I never need to use because I use this just for my hobby. Well, in my ultralight, I did an awful lot of the jigs and stuff for my ultralight wings with 3D and stuff and printed out parts and things to hold things together. But when you're thinking about doing this, there's a reality to it that really sucks, and it's the expense. Now, Fusion 360 does have a hobby license where you can use it, but I use some of the features on it where I have to pay for it. And I think I pay $400 a year for it, something like that, or $446, or maybe it's $389. But I also spend about $200 a year on AutoCAD. So right there is about $600 or $700. I have 2 or 3 other softwares I pay yearly. So in all, I pay $1,000 a year for my software to do my design. And it's a reality of it, but not everybody can just go out and afford to do that. So, but if you're just wanting to design airframes, you can still do it old school and draw it. Okay, you can get a pretty, I mean, there's some free, I think, still AutoCAD or CAD systems out there that you can still download and use that are still decent for doing airframe design. But when you get into the 3D world, and there is some 3D software out there that you can use that you can create. So basically what you want to do is you export out of your software what's called an STL file. And then in that slicer program I just showed you, which is Simplify 3D, you produce a G code, and that G code goes into your 3D printer, and then you print your part, okay? And look, 5 years ago, 6 years ago, that terrified me. I didn't know what any of that meant. And now, subconsciously, it's what I do, it's what I breathe, it's what I eat. So the reason I'm kind of stumbling around right now is I'm trying to figure out the right words to explain that there is a frustration level to me that's second to none when you are first designing in any CAD program. You learn to draw circles or spheres or rectangles, triangles, whatever you draw. And then you start to try to draw like something airplane related. And you start to realize, wow, I don't know anything yet. Now, there's a little secret though. There's a software called CompuFoil. And CompuFoil will design in CAD all your wings, your stabs, and your vertical stab and horizontal stab. So some people will think that I draw each of my ribs in AutoCAD. I don't. I go into CompuFoil, look it up on the Google it, and you can design your wings, export it as a DXF. Now you've got your CAD files to plot and cut out your wing parts. But fuselages, I have to do it old school in CAD and draw it. So if you're wanting to do airframes, that's one thing. If you're wanting to do 3D, that's a different type of software. But ultimately, for me, I start with a sketch. Well, I start with the subject. What do I want to do? What do I, you know, and it's interesting because I can have 5 people look at the color red, and everybody will say, ah, that's not really red, that's fuchsia, right? Or it's this. Or if we're under fluorescent light, it will be a different color red than if we're under daylight. Everybody has a different interpretation of just about everything we do. So the best way I can explain design for me, because I'm just trying to share my own thoughts for you to be successful, is you need time and patience. When I think about how many times, most of my design work I do is late at night when everybody's asleep in the house, or it's early in the morning when I wake up and I can't sleep. Because you really want to get your favorite beverage. You want to have some kind of soothing music or music that is more calming. You don't want Twisted Sister screaming. Because when you start to really get good, you then start to realize how much you really don't know. So it takes time, folks. I've had a lot of emails say, look, I've had Fusion 360 for 6 months and I can't draw anything like you, Dag. It depends on a couple of things. How fast of a learner you are, how much you see 3D. I can imagine a V8 engine right now and see the cylinders, the rings. I can see the connecting rod pin. I can see the bearings. I can see the crankshaft. I can see the timing gear, the timing chain gear. I can see all that in my head. If you can't see 3-dimensional, it's going to take you a little bit longer to learn to create in 3D. But if you watch like Lars Christensen on YouTube, you should be able to kind of master the basics of Fusion 360 in 6 months. But you need to have that imagination and creativity. How are you going to create that part that is functional, that is 3D printable, that is going to look scale enough for you? One of the things that have always been hard for me is to take the time to put rivets on things. Sure, I can draw rivets and I can span them all over my part, but I almost would rather have a kidney stone than to put 2,000 rivets on a 3D printed part. Because once you learn to 3D print, you start to realize unless you're printing really, really thin layers with a really small nozzle, those rivets aren't even going to show up in your print. So look, everybody, I don't want to scare you away from it, okay? But and people say, Dag, I want you to do a design basics video, or the basics of design. Nothing I do is basic. So it's hard for me to articulate to you all that what I've learned has taken me 20 years. I've had people say, oh my gosh, I could never be as rich as you because look at all the equipment you own. I'm not rich. I've bought it all over 20 years. If I was to go out and buy all the plotter, lathe, mills, everything I have right now all at once, I wouldn't be married. And my daughter wouldn't be going to college. So, I'm trying to be positive here because there are some people out there that don't have much imagination. There's some people out there that just aren't that creative. And I don't know what to do for you. Now, if somebody reaches out to me and says, look, I'm trying to figure out how to do rims for a P51, I will show you the really thick patience I have. We will share emails, and I'll get you to the point that you could probably draw a rim for a P51. But somewhere in there, you're going to have to get creative on how detailed you want that, or how you want to build it light, or do you want to put bearings in it? Almost all of my big airplanes have bearings on the wheels, and people are like, man, that rolls great. I'm like, yeah, it's got bearings like a real airplane. Well, wait a minute, how's it stop? Because I put brakes on it. You got brakes on a model airplane? So look, people, you've heard me joke a couple of times that flying model aircraft is like crack and heroin. I've never done a drug in my life. But when you hear about addiction and you hear people talk about addiction, model aircraft and building and flying them is so rewarding. It's one reason I always argue to get kids into model aircraft when they're like 6. They don't have time to become bullies. They don't have time to become mass murderers. They don't have time to go around and treat animals bad. If they're in model aviation and they're addicted, that's going to be a big part of the rest of their life. And guess what, folks? There's science, physics, teamwork, learning. There's so many skills that come out of designing model aircraft that for a kid, they're not going to have time to get in trouble. But if you're an adult and you've watched me build or design one of my airplanes and you're like, I want to do what Dag does, I would say start off simple. Okay, I would start off by, if you're going to design in Fusion 360, design a seat for your airplane. Design fake guns for your airplane. Design maybe a landing gear door for your airplane. Design some simple things in the beginning. To build a four-row radial engine to be 3D printed would be a challenge for me. And I've done a couple of commissioning where I did a third scale radial engine for a B-25 Mitchell, and it was one of the hardest things I did because the cylinders wouldn't 3D print as a half on my bed. My print bed wasn't big enough, so I had to break that cylinder into 4 pieces. And it kind of was a disaster, at least from the design point. When it was finished, customer loved it, thought it was the sexiest thing in the world. But I guess what I'm trying to really get across to you is you've got to have insane drive like I do. You've got to have insane commitment like I do. If you're going to really master this stuff, and I still don't think I've mastered it, because I still sometimes will go to draw something in 3D and have to relearn. Now, here's one of my biggest pet peeves. I have DAZ Studio for my 3D stuff that I do the renderings of my airplanes and my model, my characters and on a lot of my stuff that goes in the thumbnails. The way you use your mouse wheel and the left and right button and your shift and control is completely different than Fusion 360, completely different than, and Fusion 360 is completely different than AutoCAD, and AutoCAD is completely different than my Simplify 3D. So sometimes when I open up these softwares, it literally takes me a minute to learn what the shortcuts and how to use the mouse. So a design basics video is learn how to sketch, learn how to pick a subject that you could actually design. I had somebody reach out a couple of weeks ago and says, Dag, I really want to scratch build a P-40 Warhawk. And I said, get a Gillows kit. And they were like, what? I said, get a Gillows kit. But I want you to do is take the drawing that comes with it, go to Kinko's and double it, and cut out all your own parts, build your Gillows P-40, and then sheet it. And to tell you the truth, he is doing a really good job. I don't know if he'll let me show the picture in the next month or two, but it's looking really, really good. He's going to put a little electric in it and fly it. You got to start off with pieces you can bite off and chew, folks. I would not say your first scratch build should be, and let me rephrase that. He wants to build a ginormous plane. So what I would not recommend doing is buying a set of Zeroli P-40s drawings, blowing them up another 25%, and making that your first scratch build. Personally, I would go find an old Top Flight kit and build that kit first, because today's we're flying a lot of ARPs. There's not a lot of kit building. Building a kit and understanding the way that either Goldberg or Top Flight or somebody had laid out that kit and the instructions to build it will help you a lot in understanding how to assemble and build yours. But ultimately, it helps you understand how to design and draw the airframe. So, but I always go back, learn how to sketch. First, learn how to pick the subject that you're going to build. Okay, and look, I have started down the road on a massive B-47, and it always gets put on hold because I want it to be perfect, and I know perfect doesn't exist, but I've drawn about 25% of it, and there are a lot of things going into that airplane if I'm going to build it light and get EDFs the right size to fit in those nacelles to look scale. The EDFs are now powerful enough, but you got to keep in mind, you can't put here's one of the things looking into the world of design that you need to think about. And I'm going to use that P47 as an example. I fly only electrics right now. Nothing against gas and glow. I did that most of my life. I still love them, but I love electric. When you have an electric system, you have a battery, electronic speed controller, and you have a motor or a ducted fan. Okay? The distance between the battery and the electronic speed controller needs to be a short distance, because that speed controller, and I'm going to say this in simplistic ways, is opening and closing so many times a second, either to let whatever throttle position you want out. So if it's opening and closing half the time, you're at half power. I'm just giving you a very general basics here. But the wire between that electronic speed control to the motor can be significantly long, and I've done a lot of testing to see how long you can get. And it depends on motor, because some of my Hacker A16-L, Hacker A60-16L, I can go 10 feet without having chattering when it starts. Some of my ducted fans I had, I can't remember who made them, I can get out to about 72 inches and it still starts no problem. But imagine a P47. I've got 6 ducted fans out there, or EDFs out there, and the motor and the engine pods. Where's my batteries going to go? Where's my ESCs going to go? They all have to go in the fuselage. All of it. And then I need to figure out, how do I take these wings on and off at the field and transport the airplane? Well, that means I'm going to have to be unplugging the radio plug to each EDF and the 3 wires that make up the DC 3-phase going to the motors. And I hate connectors that I take apart and plug in, because as those start to wear, your EDF timing will get screwed up or it just won't run. And the timing is when it starts. So my biggest hurdle on this huge B47, well, that's not the biggest. The biggest is landing gear and the spar. And I mean, there's so many things about this B47. And I've been doing my own designs now for over 20 years, and this is still a huge challenge. Okay? So I know I got real wordy there, and I went down that path because I'm supposed to be talking about basics. But the best way to get into design basics is honestly design, if you're doing 3D, design a seat for your scale airplane. Design fake machine guns for it. Design little bitty parts that are going to be accessories to it. Okay? Don't design a 4-row radial as your first attempt. Okay? But another thing is you got to have fun. One of the things I did early on with 3D was downloaded from like Thingiverse and stuff, different widgets that I could 3D print. Dragons, astronauts, just crazy stuff. So I could get really, really proficient at 3D printing. But then I would take some of those G-codes into my Simplify 3D just to kind of look at maybe the way it was drawn. And then I would actually take that raw file from Thingiverse and open up that STL or the Fusion or whatever format it's in, and look at how the creator who designed and created it. Okay? So I've done my best, folks, to try to explain the basics here, and it's almost like I had a friend one time, really big muscle guy. One of my friends says, "Oh my gosh, dude, how did you look like that?" And he joked and he goes, 2 hours a day, 6 days a week for 15 years at the gym. And I laughed because there was a rock movie where he said something like that too. Nothing really wonderful is easy. Nothing really wonderful can be done quickly. And all I would say is just stay with it no matter how frustrated you get. And understand when to pause. And what I mean is walk away from it. I've walked away from projects for a whole year. You need to also understand when to go do something different. So let's say you're trying to draw a radial engine and it's a disaster. Go draw something different in Fusion, or download somebody else's design and look at the way they did it. rewire your brain to get away from that frustration. Okay. I've had a lot of people ask me, how often you get frustrated. Early on, all the time. I've always been such a perfectionist that if something didn't look right. I would say it was about 8 years ago where I learned to not give an F. It just happened one day where I just decided, screw it, I don't give an F. And at that point, my life got a lot better. And I just started like chilling out and taking my time, especially on my design side, to realize, and my wife says this to me, she said, is there a date that this has to be finished by? And I'm like, no. And she goes, then why are you killing yourself that it's not working right now? And so don't set dates saying, okay, I'm going to have it done by January 1st. Don't do that. Okay? It will get done when it gets done, and you'll be a lot more happier. So keep reaching out to me, folks. If you've got any ideas on how I can better articulate and explain this, let me know. If you want me to zone in on one subject, let me know. But when it comes to design, it's become a subconscious thing to me now. And it's like a language I can't even explain where my brain's been able to go. And I definitely wasn't there 25 years ago. I remember the day I bought that BricsCAD, AutoCAD software, opened it up, and I didn't even know how to draw a straight line. I didn't know what to click so I could draw a straight line. And I look at what I do now, and I always joke that it shows that even an idiot can be taught to do cool things. And I know I'm not an idiot. But yeah, that's it, folks. So I'm going to quit jabbering here. I always want to end my videos asking you to get youth involved in model aviation. I've already touched on it a little bit here. But if your kid is 8 years old and sitting at home playing a video game where he's killing a mall full of people, that's probably not the best way to get to Carnegie Hall, okay? But with model aviation, it's one of the greatest things that you could give a kid. Boy, girl, it doesn't matter. If I could teach my dog to fly, I'd be teaching my dogs to fly because it is such a cool thing to be a part of. And just keep trying. Don't give up. Don't give up, because design is it's a completely cool world. Once you I had a neighbor one time look at me and said, you could design just about anything. And I said, I probably could if I had the funding. And you give me $7 trillion and I'll get us to Mars in 5 years. So rock on, everybody. I'll see you next time. And thanks for all the wonderful comments. And all you haters, I love you just as much, because it cracks me up that you have nothing better to do than come on my YouTube and tell me I'm full of crap, because that means you've got a really pathetic life. I'm sorry to say it like that, but I'm here to try to share joy. And if you want to come in here and hate, you're cracking me up. Be safe, everybody, and rock on. See you next time. Bye-bye.